Welcome to Electric Perspectives, a podcast that explores the innovations and policies shaping the electric power industry and how America's electric companies are delivering the resilient energy we need to strengthen America's energy security and power our daily lives. This show is brought to you by EEI, the Edison Electric Institute, which represents all U.S. investor-owned electric companies. I'm your host, Brian Reel. Duke Energy Florida's DeBary hydrogen production storage system is the first end-to-end system in the United States capable of producing, storing, and combusting 100% green hydrogen. Joining us today is Duke Energy's Senior Vice President of System Planning and Construction, Regis Repko, to discuss how the system works and what it means for reliability, affordability, and delivering value to customers. We'll also explore what this project could signal for the future of power generation. Regis, thanks for joining us.
Thanks, Brian. Great to be here.
Duke Energy recently unveiled this DeBary hydrogen production storage system. What makes this project unique and why is it significant for the electric power industry?
Thanks, Brian. As you mentioned in your intro, this is really the nation's first of a kind integrated project using green energy to produce hydrogen that can then fuel gas turbines. The reason that's so important is there have been a number of demonstrations done within the industry. Those have largely been in terms of a contained volumes of hydrogen. Think about cylinders or gas truck deliveries and demonstrating the burn of hydrogen in combustion turbines. This is really the first, when we think about the future in terms of a high penetration of renewables, the opportunity to have that produce then the hydrogen, which could fuel gas turbines. It's going to take an integration of each segment of that in a project to perform that function. So this is really the first project of its kind that does just that.
And how does this project align with Duke Energy's broader reliability goals?
Yeah, this project is really going to give us some information and insights about what is the role of hydrogen going forward. If we think about a future with a high penetration of renewable energy, those renewables are, produce their maximum output at peak days. Think about at 10 a.m. to 2 p.m. when the sun is most overhead, right, where solar produces its output. The challenge is we need this energy really at 5 a.m. or 5 p.m., right, early in the morning, particularly in winter, in the summer, 5 p.m. at the hottest parts of the day. So, really, if you think about it in a simple context like that, how do we store this sunshine is really what the role of hydrogen is, such that we can have it available to use in a dispatchable way through gas turbines to provide that peaking power at 5 a.m. and 5 p.m. as well. So this will give us a views in terms of the operation and cost aspects with that then we can really utilize in terms of our analysis to navigate what that future looks like such that it best serves our customers.
And can you walk us through at a high level how solar energy is converted into green hydrogen and then how it's stored and used in existing turbines? And also maybe what does it look like? If you were to walk onto the site, what might you see?
Yeah, I'd be glad to. I think first let's start off with this term green hydrogen. So all hydrogen is colorless and odorless. So the industry has developed this color designation of different types of hydrogen. And all that does is really identify the source of producing the hydrogen. Most of the hydrogen produced today is what would be called gray hydrogen. It's produced by stripping the hydrogen from natural gas. Other types of hydrogen include pink hydrogen, which is the energy comes from nuclear. White hydrogen is what exists naturally in the earth. Green hydrogen is the type of hydrogen that is produced from renewable energy. So, the way the system works is that energy is produced at DeBary from an existing solar project that they have on site. That energy, in turn, powers electrolyzers. Electrolyzers take that electric current and water, and it breaks down the water into hydrogen and oxygen. The oxygen is released, and that hydrogen is subsequently stored in cylinders. When needed, that could be used as a fuel to power one of the gas turbines at DeBary to produce electricity. So, if you were to walk on site at DeBary, you would clearly see the 75 megawatt solar facility, that project that's at the existing site. And then very close by and adjacent to it, you would see some physical compartmental containers. Think about shipping sea land size containers that contain these electrolyzers. And adjacent to it, you would see several large racks of cylinders by which the hydrogen is stored. That has piping that goes literally across the street to the gas turbine there at the site to power it. So it's a pretty, with the exception of the solar project itself, it's a pretty contained project in terms of physical parameters.
And you spoke a little bit already about the ability to shift the time of production. How does this more broadly enhance grid reliability for Duke Energy and support the integration of even more renewable energy in a sunny state like Florida?
Yeah, it's all, what we use is the term energy arbitrage, right? How do we move this energy that where we might have excess to times of the day when we would need it most? So it's back to that really storing sunshine where we have excess energy at that peak day, being able to use a system such as the berry to make hydrogen and store it. So as we think about more and more renewables coming on, that just increases the capability or the opportunity around that. The advantage of that is that you can really size these kind of projects to power gas turbines that can operate really in terms of durations to meet the needs. Right now you think, well, why not use batteries? So the technology around batteries is largely lithium ion. They're typically around a 4-hour time frame. If you use hydrogen to power gas turbines, you have far more flexibility in terms of that resource to run. Really, you could run many hours past 4 hours if need be, and you got a project size beat that. So it's really around that flexibility.
And customer affordability is top of mind for our member electric companies, for a lot of policymakers, and of course, customers. How does deploying green hydrogen help Duke Energy manage cost and deliver value for customers? Or how are you thinking about it as you demonstrate it?
Yeah, that's exactly what we're seeking to learn with this pilot project. Affordability is first and foremost in our minds in terms of our customers. So this is around really what role does hydrogen serve as a potential resource to really optimize the system and particularly the system generation. And what I mean by optimize, that really comes into play in two aspects: the generation and the fuel. So, fast forward with a high penetration of renewables, the ability to produce hydrogen to scale, and being able to use that in gas turbines as a dispatchable resource has the potential opportunity to forego additional builds, right? And use the existing resources we have on the system in that way. The other aspect is around the cost of fuel itself. In terms of what will the future costs of natural gas, we foresee that really take a look at the what they call the long-term curves associated with that increasing costs. As we continue to refine and really mature our manufacturing and development of hydrogen and associated projects, has the opportunity to greatly reduce those costs. So there an intersection there that the fuel itself becomes a competing opportunity and save customers money. So it's around both aspects, right? Does it optimize the system such that I can eliminate some future generation bill? And then as a fuel itself, does it have future opportunity to be, a very cost-effective resource for our customers?
And could there be some cost savings because you're producing it on site? You're not having to ship it in or build pipelines to transfer it around?
Absolutely. I mean, particularly in terms of shipping, that becomes very impractical when you talk about the volumes of hydrogen that would be necessary with that. So, in terms of trucking it in transportation, that's really a long putt as we see it right now. Now, is there the opportunity in terms of, mass production that can be blended into existing natural gas supplies? Absolutely.
Are there any lessons from the DeBary project yet that you think would be of particular interest to other companies as they're looking whether it's to integrate hydrogen technologies or even other emerging technologies?
Yeah, there definitely are. There's been a lot of learnings for us, and we are eager to share those with the industry. There are other projects in the US that are currently in flight around the use of hydrogen power gas turbines. The Los Angeles Department of Water and Power has a project underway. There's another one by Intermountain Power in Utah, a couple of others. And we have been engaged with them with a very aggressive exchange between the two of us to share learnings on where we're at with each project. So, some of the things that obviously we've learned that we've conveyed already is I think, first and foremost, this can be done safely, right? Obviously, we would not embark upon a project like if it can't be safe. And we have clearly demonstrated that. We've got some learnings in terms of I'll say it's sizing of the fire suppression systems. Hydrogen burns very differently than natural gas. It's hotter, has more energy per volume. So that takes that into account. An interesting learning that we did not anticipate, Brian, in terms of carbon monoxide emissions. If you burn 100% pure hydrogen, you have zero carbon monoxide emissions. But what we learned is that with really small amounts of hydrogen additions, blending in the gas turbines, the carbon monoxide emissions drops significantly. It's not linear. So that presents a whole new opportunity for us that we didn't anticipate in terms of the turn down, how low that we can operate our existing gas turbine fleet. That in turn could factor in the cost savings for our customers in terms of precluding new generation build, but that remains to be seen. But there are other things that we've learned as well in terms of how to perform siting studies, the nitrogen purge system. To do maintenance, you want to purge the hydrogen out of the system. You don't want to use air, right? Hydrogen and air would be a flammable combination. So you use nitrogen. The volumes needed are far more than you want to practically bring in, like on a truck. So we actually altered and put in a nitrogen manufacturing system itself to do that. So again, a whole host of learnings that we've gotten out of this pilot project that we've already been conveying and are eager to share with the industry.
And as you said, hydrogen has different characteristics than natural gas. So as you're working to procure new turbines or upgrade existing turbines, what sort of work did you have to do to make sure that you had the right turbines for this type of system?
Yeah, great question. So, we've worked in partnership with GE Vernova on this project, and they were invaluable to the success of this project as well as other equipment partners with that. What they were able to do in terms of their analysis internal to the engine, the material compatibility relative to the temperatures it would see, the purging processes and how that would need to take place to the turbine. The fire suppression was all done and analyzed by GE Vernova along those things. So they were instrumental as a partner, as were others in this. But I think, as the industry advances these kind of new technologies, and in particular, as we're talking about here, hydrogen, these kind of, business partnerships between the different whether it be the electrolyzer manufacturer, the turbine manufacturer, and the generator itself are going to be essential to make sure that these analyses are thoroughly vetted and executed within the project.
And looking ahead and it might be too soon to say, but is Duke Energy exploring ways to scale hydrogen technology to other sites?
Well, first things first. We've got this project in, like I said, first of a kind for the nation in terms of a fully integrated project from solar panel to electrolyzer to storage to combustion turbine, gas turbine. So we're in a learning mode for now. We want to take it the opportunity to operate DeBary for a period of time, really understand how it operates, what is the maintenance aspects, associated costs with that, frequencies of maintenance, how the overall system cost comes to bear against our predictions, and how can we best optimize that, in terms of, scheduling hydrogen production versus system energy on the grid. So, we're going to do some operations of DeBary for a time, get this data, and really what that will factor in is into our future analysis in our generation resource planning. And that will really, as we look at formulating our least cost portfolios to the benefit of our customers, that will really determine hydrogen's role in terms of time frame and quantity.
And how does hydrogen fit into the US energy mix?
Hydrogen should be viewed as really a complementary and flexible resource. It's really part of our overall all of the above strategy in terms of how does it fit in. The role, whether it be small or large, and when, again, is part of the work that we're doing right now and beginning. But we're eager to learn that, and we'll reflect that in our future resource plans.
Well, it's exciting to watch how these partnerships are helping America's electric companies deliver the energy of every day. So, looking forward to continuing to track this project. And as you learn more and share more, we definitely will tune in.
Well, thanks for having me. Be glad to update you in the future.
And that's our show for today. Thank you for listening, and be sure to subscribe on Apple Podcasts, Spotify, Podbean, or wherever you get your podcasts so you never miss an episode. To learn more about EEI's members and the electric power industry, visit our website at eei.org.